Well, welcome everybody to our first meeting of 2024. We appreciate you coming. Tonight we have a great guest speaker to kick us off for the new year. We've got James Serra here, who's going to be talking on the subject of deciphering data architectures, choosing between a modern data warehouse, data fabric, data lakehouse, and data mesh. So our agenda for tonight, we're just going to do a little bit of networking and introductions, which I'm basically doing right now. And then we're just going to jump right into the topic as well. So by way of background for Toronto data professionals, we have a lot of new members that have joined recently over the past few days. So the Toronto data professionals is one of the largest data professional communities in Canada. We have monthly meetings that offer interactive learning. It's built by the community and it's guided by trusted experts. Our next event will be on February 21st. We'll be talking about what's new in Azure Databricks. So that event should be up on Meetup. So go ahead and register for that one if you're interested in attending. We also like to thank our data and advanced analytics team from OMERS, who's partnering with us to help us foster this learning environment. If you're not aware of what OMERS is, it's one of the largest defined benefit pension plans in Canada. The data and advanced analytics team is part of that organization. They've got different roles in advanced analytics, including BI, data science, data engineering, and you get lots of learning opportunities. So it's a great place to explore if it's something that you're interested in. Okay. Okay, so based on that, that's our intro. So James, I'm going to hand it over to you. So I'm going to stop sharing here. And again, I'll remind everyone just to make sure you're on mute. And James, I'll let you take it away.
Awesome. Great. Well, welcome everyone. My name is James Serra. I'm a data and AI solution architect at Microsoft. There's my email. If you have any follow-up questions, be sure and shoot me an email. I will pause along this presentation to take questions. So either drop something in the chat or just raise your hand or just come off mute when I have those pauses. I've been doing this for quite a long time in IT, almost 40 years now. I've had all sorts of roles, and I've put everything I've learned over the last 20 plus years, maybe longer, into this book that's upcoming. This presentation, which I started doing maybe 3 or 4 years ago, was expanded into this book that's coming out in about a week and a half. You can pre-order it now. So if what I talk about interests you, just feel free to go and check out the book if you want to go in a deeper dive. The topic is data architecture. There's a lot of data architectures, there's a lot of conversations about data fabric and data mesh, and a lot of people are getting confused. So if you try to understand this on your own, you may wind up like Towelie here, for those who are South Park fans. So we're going to try to prevent you from getting really confused. Hopefully I don't confuse you more through this presentation. What we'll cover here is we'll talk a little bit about relational data warehouse and a data lake, kind of level set those concepts. The book goes into much more other concepts in here, but the two that are central to the 4 architectures are those two, and then we'll dive into the 4 architectures: modern data warehouse, data fabric, data lakehouse, data mesh, and then, time permitting, I'll have a few slides on data mesh on Azure, which covers Microsoft Fabric. These opinions are James Serra's, not Microsoft. So please don't go back to your company after this presentation and say, well, Microsoft said this. No, James Serra said this. Microsoft doesn't really have official opinions on these things, and it could be different depending on who you talk to at Microsoft, but they'll be pretty close most likely. But these are all my ideas. And so let's start out with the relational data warehouse in here. Hopefully most of you are familiar with data warehouses, know why you have one, but I'll get into that. Even with these other architectures where you are going to centralize the data, you're going to copy it, whether it's in a data warehouse or a data lake. The reasons you do that are all still very similar in there. the general idea of a data warehouse is you're taking data from many sources, you're ETLing it into a data warehouse, and then you're reporting off of that. This everything I talk about is dealing with data warehouse solutions, not OLTP applications on here. And the whole point is to make better business decisions when you're trying to gather all this data and you want to get insights and make those better business decisions. And to do that, you need to have some sort of architecture. That architecture may have a relational data warehouse in there, and the reasons you have a relational data warehouse are listed here. There's a lot of them. The biggest one is reducing stress in the production system. I was a DBA for about a dozen years, and I ran into those issues where somebody's got a query that's malformed, that's running on a production system, and they're trying to generate reports at the same time people are trying to enter all this information, and the server gets overwhelmed, and I got to do the kill command. So one of the big reasons for data warehouse is to copy all that data from the source system, land it into another location, and then report off of that. When you do that, you can then optimize that data for reading, where on the source system, it's optimized for a lot of updates, inserts, and deletes. In a data warehouse, it's write once, read many, so you can put lots of indexes on that, because you're not really worried about the writing part of that in theirs. And then you get into other big reasons like renaming the fields and the tables. So a lot of these source systems, especially ERP systems, I still remember this one that was T116 in there. Well, nobody knows what that is. So rename it when you put it into a warehouse, because in the end, you want to have self-service BI. And to do that, you have to make it easy for people to understand on that. And so that's another reason to have a data warehouse. So many more. Won't go all into that. I'll have this deck available afterwards for you to have as a reference. So that's relational data warehouse. A data lake, and the big difference between a data lake and a relational data warehouse is a relational data warehouse is schema on write, meaning, I don't know if I put that in here. Nope, I got to put that in there. I'm just writing down the note for this. Apologize. And the schema on write means I need to do a lot of upfront work. So I may have to create a database, and then a table, and then a schema, and then fields, and then write all the ETL to go in there. So it's a lot of upfront work before you can even put data in there. With the data lake, it's schema on read, meaning no upfront work. I just simply copy data into this file folder. It's like a glorified file folder that you have on your laptop, except it's got a lot more features into it, and it's scalable, and it's in the cloud on that. Maybe more like OneDrive, and it's just as easy to land data in there. You just copy it in there. Schema on read means when you pull the data out, you have to apply the schema to it, and that's where some of the challenges come into play. But the data lake's much better than relational data warehouse for collecting data that it could be very large, or it could be streaming IoT data, and their social media feeds can go in there. So a data lake is just much more encompassing than a relational data warehouse, but it does have its trade-offs, which I'll talk about. And so the big reason for a data lake, if you think about building a solution with just a relational data warehouse, you're going to load data in there, and usually you load it at night, and you have a maintenance window, and you kick people off, and then you load all the data in there, and it takes all this compute, and it's loaded in the staging tables. It's transformed and put in production tables, and then you can let people back on, and hopefully nothing goes wrong. Otherwise, people start complaining because the data warehouse is not ready yet. Well, at the very least, with a data lake, you can take those staging tables, and essentially you put them in a data lake, and you copy the data from the source systems in the data lake, and then within a data lake, you do all the transformations. And it could be even more powerful because a data lake is just storage. You can apply many different types of compute that's usually cheaper and faster than what you have in a relational data warehouse. So you can do all that cleaning outside of the relational data warehouse in there. So that can be run 24/7. You may have a short maintenance window where you're loading the data after it's been cleaned, but much greatly reduced of colliding with people who are trying to use the relational data warehouse in there. So that's a big reason. And then others could be that when it just takes seconds or minutes to land data in the data lake, it make it very available to people right away to start using it, because all that work up front doesn't have to be done. That was challenging when data lakes first came out because of the technology to access the data, but it's gotten so much better, especially with something of Fabric, that we're seeing more people use everything in a data lake, which we'll get into our data lake house in a minute. But data lake, very popular. Everyone that I deal with at Microsoft is using a data lake, and then it becomes, okay, what architecture is going to use a data lake and a data warehouse, a relational data warehouse, and that's the modern data warehouse in there. The idea being, I'm going to go through 5 steps: ingest, store, transform, model, and visualize. Most people have these 5 steps in any solution in there. Maybe they call them something differently, but the idea is you're going to ingest and store it into a data lake. At that point, the data scientist person may say, I'm going to do machine learning and train on that data in a data lake, and they're off and running. The others are going to take the data and model it into a relational data warehouse. So it'll copy the data into their normal form, maybe a star schema, and then people will visualize off of that. So you're using both a data lake and a relational data warehouse. This has been the architecture maybe the last 10 years or so that has been very popular in there. It's changing with the lakehouse, but customers still continue to use this type of architecture. When using both the data lake and data warehouse at a very high level, you can think of the data lake as the staging and prep area, and then the data warehouse is the serving, security, and compliance layer on that. Many reasons for that, big ones being that the data warehouse has a lot more security options on it than a data lake. For example, row level security does not exist in a data lake. Column level security doesn't exist in that. So if you need those functionality, you would copy it to a data warehouse. Now, this is changing, but traditionally that was the case. And then there could be end users who are just used to a data warehouse in there, and so you give them that same interface that they've had. So this is where these two separate products have coexisted, and you kind of get the best of both. The architecture, what that looks like then is this right here. You ingest all this data, you land it in a data lake. The data lake itself would usually have multiple layers in there. You may take the data as it is, land it into the raw layer. At what point you may have another layer conform, so all the data can come in as JSON and CSV and Parquet. And the first thing you do is make them all Parquet. And then you say, okay, now we're going to use that data lake compute to pull that data out of raw, clean it, land it into the clean layer. And then we still may need to do more with that data. We may need to aggregate it, join it, master it, and that will go into presentation layer. And so you want to think a lot about data lake design, because you may have more layers than this. Then each of the layers has individual folders in there. You separate them out for reasons such as security or performance. So data lake design is something I sometimes spend a whole day with customers to go through, because you want to build something that's going to last for a long time, and it's all going to be different based on the size, the speed, and the type of the data. If you're familiar with Databricks, they have the medallion architecture, gold, silver, bronze. I use more descriptive names for that. So we take care of the storing and the transformation of that. Now we want to copy some or all of that data into a relational data warehouse. It may land in there in third normal form. We may want to then convert it to a star schema to make it easier for the end user to visualize that data. So if you look at this, there's complexity. There's multiple copies of the data. But the benefit of that is IT will do all this work to have, in the end, maybe an easy to understand star schema that end users can use self-service BI on, and not have to go and bug IT to build reports for them. And so that's the ultimate goal. So do all this upfront work and have the end users go build reports and dashboards and write queries all on their own. This is given way to what I call a data fabric, which to me is a evolution of the modern data warehouse in that it adds additional functionality on top of it. Listed here could be things like in, I think that's blue, in metadata, where you're using a product like Purview to catalog all the data. You can be doing master data management, additional security APIs. All of that is added into the traditional modern data warehouse on that. And think of the fabric. It goes out and it's has all these fabrics that are ingesting data no matter what the size, speed, and the type. Now we can get to real-time processing. We can write APIs that are going to be used to access the data, not just connection strings. So it's just handling more data. Now, some people will replace the term modern data warehouse with data fabric. Others go in another direction. If you look at Gartner, they talk a lot about what I call the intelligent data fabric, where it automates collecting of all this data and it uses knowledge graphs and what like that. And I don't see anybody building solutions like that. So I don't go and talk about that in there. To me, maybe that'll come, but right now I just call it the regular data fabric in there. But how that looks is like the modern data warehouse, except we're adding more features and functionality onto it in there. So it's more complex. The benefit of that is you don't have to say no to an end user who says, I want you to ingest more data in there. Maybe it's real-time data and it's a lot of it. You can go, no problem, we've built this data fabric. It can handle all sorts of data. All right, so that's the first two that I went to pretty quickly. Asking some questions on here. One of them is, what happened to SQL Server Analysis Service multidimensional and tabular cubes? Are they still in the game? Sort of. If we get into products, and what I do with customers, and I talk about a lot in the book, is do architect design sessions. So I'm gonna, and I just did this yesterday. I sit with a customer all day. I do discovery. I ask them a lot of questions. Those questions are going to result in a whiteboard of an architecture. And at first, I don't even talk about products. I just lay it all out. And then if they're Azure customer, which they are in my world, I'm going to put Azure products in there. But I could very easily put Amazon or Google or mix them up. Maybe they use Informatica, and I could say, okay, where that goes. If I get into the products like Purview underneath the covers uses the tabular model. So that used to be, and it's a good point, I used to have it sitting in here as the data would be copied into a cube and aggregated. Now that still happens, but there's a tabular model within Fabric that does that, and within Power BI that does that. And I would say within the last couple of months, they've finally added all the features that SSAS had or Analysis Service had into the tabular model. So it's a superset of now. It can do everything that did plus some. So yeah, you're still using cubes, but they're inside of the Power BI tabular model. Now, this is where I ask customers, if that's all well and good, but if they come and say we're not using the tabular model, I mean, we're not using Power BI, I would then say, well, maybe this is a case where you would want to use Analysis Services on that and open that up. So to other reporting tools in there. So there's exceptions to this. And as complex as this looks, it could be a lot more complex if we start diving into some of the products and the exceptions that a particular customer would have. But in the end, you have to get the performance you need from queries, and that may mean doing things like creating a cube outside of this for other products and whatnot. So yeah, thanks for that question. Anybody else, just raise your hand or put something in the chat. So now I will jump into the data lakehouse. All right, I just want to take in some coffee, make sure I don't lose my voice. A little bit of history for you. For those as old as me, who've been around in the 80s and maybe started out as COBOL programmers like me, you remember back then, Teradata was handling big data. Of course, big data at that time was what, a terabyte now in my little phone here. This is way more than you get back then. And these were all encompassing systems. So Teradata, eventually Netezza, would have the relational storage, the relational compute, the ETL, the reporting tool were all out of the box. And that worked great for many years, still sort of used in some customers that I see nowadays, especially if they remain on-prem, which I don't know why I'd want to do that, a whole other subject. And I do talk about in the book, I'm plugging it a lot here, but there's a whole chapter on why move to the cloud, so you may want to check that out. What came around in the late 2000s was data lake, which, and I always joke, was this magical land of unicorns and rainbows and leprechauns, a lot of little leprechauns. That data can just be put in there and it'll magically come out all nice and pretty. You don't need relational data warehouses anymore. I had customers actually come to me and say they were going to do that, get rid of their relational data warehouses. I said that's a really bad idea. They went down that path. They came back later and said, yeah, that didn't work. They fired the CIO whose idea was and it failed miserably. And the big reason of that is the data lake was complex, and the technology was not there yet for people to easily pull data out of it. Imagine if you're an end user with a lot of technical knowledge and somebody comes in there and says, hey, we put all the data you want, it's sitting in files and folders, go use Hive SQL and have at it. People would go like, what are you talking about on that? So big failure there. However, there were still some benefits of the data lake. So instead of using the data lake for everything, the idea was use it what it's good at. And that was what I talked about before, transforming the data. So that's where we came up with the modern data warehouse list that's already been talked about. Now in 2002, which is, my gosh, it's almost 4 years ago now, Delta Lake came about, and this was created by Databricks. And the idea was, let's do everything in a data lake and not use relational storage. Well, wait a minute. You just said that was a failure. What's changed? Well, Delta Lake is what's changed. That is software that runs on top of an existing data lake and gives it relational data warehouse like features. So the idea is all those features that didn't exist when data lakes failed at first are now added to this software layer. So it's not its own storage, it's just an add-on, a bolt-on, think of it, to a data lake. And therefore you can get away with using a data lake and not using relational data warehouse. And at first I was very hesitant, but as technology has improved, I would say 90% of customers now are going this route of using a data lakehouse because of the Delta Lake technologies. Now there are competing technologies that are like Delta Lake, like Iceberg and Hoodoo. Microsoft standardized on Delta Lake in there, and to use the product of the Delta Lake in there on the right hand side is as simple as, if I'm in Spark, I can just say I want to save it, instead of in Parquet, I want to save it in Delta format, and it's that easy. And many of the tools within Microsoft automatically save it in Delta format on there. Now, what does that give you? Well, the big one is supports SQL commands: insert, delete, update, merge. Those don't exist in a data lake. You can't give those commands in there. To do something like that, you have to take that file, load it into, say, a Spark notebook, update the rows using Spark code, and then write the whole file back out, which could take forever if it's a large file in there. Well, Delta Lake supports those commands. Now, underneath the covers, Delta format is storing it in Parquet with a log on that, and it splits up the Parquet, the file, into a lot of Parquet versions. So I won't get into the technology how it works, but it works and allows you to be fairly fast and do these commands to it. So now all of a sudden I can do a lot of the stuff that was reserved for relational data warehouse. I can do that within a Delta Lake. I have ACID transaction support for a one table on that, which you don't have in a data lake. Other things you don't have in a data lake: versioning. As the data is landing in there, because there's those log tables, I can always use that to roll back, or for auditing, or just say, I'm going to have a SQL command. I want you to tell me what this data was like a week ago. It helps to unify streaming and batch. It has schema enforcement. It gives you that. It has, so code won't blow up if somebody dumps a file in there that doesn't have the right format. And then there's a lot of performance improvements in there. And therefore customers use cases started saying, hey, you know what? I think I can do all this in a data lake using Delta format in there. And so what that would look like here is just what I showed you before in a data fabric, except we don't have the relational data warehouse anymore. And this really helps for these 4 use cases on here, in which these are the problems you have when you have both a data lake and a relational data warehouse in there. Keeping them consistent. If you have a bug in your code writing from the data lake to the warehouse, now they could be wrong in one of those in there, which can cause problems in there. You'll have a data warehouse that's older. Maybe it's only an hour older, or could be a day older, but that could be a problem. People can get 2 different answers depending on which one they go and report off of. 2 copies of the data, even though data's storage is cheap, you're still saving money by having just 1 copy of that. Also, 2 copies, more risk for security that you can have that you have to maintain in there. And then finally, you need specialized skills. You need to have people that know both a data lake and a data warehouse, or hire more people to maintain both in there. Well, that problem goes away because you're reducing the technology that's being used. So what that would look like here, very much like the data fabric, the big change here is we don't have a relational data warehouse. I do instead replace it with a relational serving layer. The reason being is it's schema on read, remember? So when you pull the data out, you have to have some schema to understand. And this is where it's challenging with the data lake, because where is that metadata? I land a file in a data lake. Well, the metadata could be the first row in that CSV file. It could be in a separate manifest file. It could not even exist. So can I make it easier for end users to understand that data? And you say, yes, I can do a serving layer. It could be a view on top of that file in there. It could be within Fabric, they have the ability to automatically create tables with a schema inside of it. So, and that could be a data set sitting, or now called a semantic layer, sitting in Power BI. You don't have to have that, but it certainly makes it a lot easier for the end users to consume that data if there is some kind of relational serving layer on top of that. And then you'll have a data catalog, something like Purview, that's going to scan all this and allow people to go and see what's already existing, so they're not reinventing the wheel. Now, this is all great, but can of worms time. Everything's got trade-off. All these data architectures have trade-off. There's pros and cons with everything. So if a vendor comes in there and says data lake's going to solve all your problems, data mesh is going to solve your problems, you have to ask, what are the trade-offs? And so I list some of the trade-offs here for a relational data warehouse. I'll just go over a couple of them. One of them being the data sitting in a Delta Lake will never be as fast as data that's sitting in relational storage using a relational engine. For those that know what an MPP technology is, you don't get that. There are workarounds or possible exceptions, what I'm going to say now, but for the most part, it doesn't have MPP. You don't have advanced indexing or statistics. It doesn't have advanced caching, query plan optimization, materialized views, joint optimization. All these things have been tried and true for a relational data warehouse, but they just don't exist, or are very limited inside of a Delta Lake in there. And then I touched on, like, role of security doesn't exist in there. Referential integrity doesn't exist in there. So you may look at all this and if you go like, hey, that's no problem. Maybe your queries are slower in a Delta Lake and they take 2 seconds, but you can say, well, that's perfectly fine. I don't need 20 milliseconds response time on there. And the other great thing is a lot of technology has now made these problems go away, or workarounds, particularly in Fabric. You can look at things like this with Fabric, which uses Power BI now, and a thing called Direct Lake makes the performance just nearly as fast in most use cases as what you get in relational storage in there. Power BI has row level security and column level security on that. So if you're using that product, that problem goes away. If you have a lot of users hitting the system in a Delta Lake, that could get bogged down. If I'm using Fabric and using Power BI and the data is all in memory, I can have thousands of people hitting it without having any problems that you would have just going right against Delta Lake on that. So just be aware of these, see if there are problems, and then if there is a problem, you can always say, well, for a particular set of data, I'm going to pull it into a relational data warehouse and avoid the problem for that particular data. But it's not an all or nothing. You don't have to go in there and say, well, all my data is got on a relational data warehouse. It'll just be a particular set of data that has to have a certain performance or feature that is not in the Delta format. Okay, great. So any questions? Feel free to raise your hand, come off mute before I get into the last architecture.
Hi,
All
James.
right, we'll start with Kelly.
Hey, how you doing there? Love the presentation so far. Quick question. So in Microsoft Fabric, you know, the underlying it's Delta Lake. That's the underlying technology. But there's still, I guess there's Synapse references, right? To that in, like, you got data warehouse and lakehouse, right? So can you actually have still the Synapse offering within Fabric? Like you said, still need a relational data warehouse to leverage all these materialized views and things like that. Can you still do that within the Microsoft Fabric environment? Or is it just, I'm just going to use Azure Synapse and kind of tie it in that way, right?
Microsoft Fabric is, think of it as taking Synapse, which is a PaaS solution, platform as a service, and making it a software as a service and a SaaS solution built on top of Power BI. All those products will store the data in Delta format, and that could be used outside of Fabric. It has additional features in there like Direct Lake that I mentioned that make it very fast. And a lot of these problems listed here go away with Fabric. The underlying technology is Delta Lake. So what's the trade-off to that? Because there's always trade-offs, James. Yes, you have to, each product that's going to use that data has to know what Delta Lake is. And most do, and Microsoft has standardized that, so all the Microsoft products do. So in the end, Fabric is a great solution for creating a warehouse. And I have another video that goes more into a warehouse and a lake house and how it all works inside of Fabric. So I don't want to go too deep into that, but keep in mind, the Microsoft Fabric is using a lake house. There is no relational storage anymore. Synapse has a dedicated pool that's gone away. Fabric has a warehouse, but it's not a dedicated pool. It's not its own relational storage. It's all in Delta Lake inside of a what's called One Lake, which is a giant data lake house. In there, everything that you use within Fabric is inside of One Lake. So hopefully that answered it.
We'd still probably use we'd still need a Synapse solution if we still wanted all those features for your relational data warehouse.
It's Fabric has, I would say, 90% of all the features of Synapse. So Synapse is, it may not go away for another 10 years, but all the resources Microsoft is doing is going into Fabric because it's a much better product on that.
Yeah, I kind of figured that's where they're focusing the dollars in there. So
right, and I'm happy to have a follow-up conversation because there are a lot of customers who are trying to build a solution to Synapse now, and and essentially how can they migrate easy over to Fabric. And it's like, we'll avoid using dedicated pools because those don't exist. And anyway, there's a lot more to it. I do have slides on that in another presentation in there, but yeah, happy to follow up with you on that.
Okay, thanks.
Yeah. Roger asked how did Delta Lake solve the small farm problem. I don't want to get into that. It's actually in the book where I talk about that, not to get you to buy the book, but send me an email and I have a link that goes into detail on how it solved the small lakes, small files problem. Other questions? Yeah, I like that. Thank you for that big smiley in there. All right, let's jump into data mesh. How to explain data mesh? It took me a lot of reading on data mesh, and the author Jamek had came out with a blog post a few years ago on this, and I had to read it many times because it's actually very confusing. And I'm going to try to simplify it to you in the next few slides. Data mesh, think of it at a high level. Everything I talked about today, the three architectures, is all about taking operational data from all these source systems. You can think of them as domains and copying it into a central location and creating the analytical data. A data mesh, there is no central location. Each of the domains, instead of copying the operational data into a central location, they will create their own analytical data off of their operational data. And then they will make it available to everybody else. So no centralization for the data, extra work on each of the domains to create the analytical data. That is, in short, what a data mesh is. Now, a data mesh is a concept, it's not technology. And it is a huge organizational shift and cultural shift that most customers are not able to do. So data mesh is for a very few small number of customers in there. However, and I'll say it up front, I'm not saying data mesh is a bad tech way to go. It's just limited to who would be able to build something like this. But at the very least, understand the data mesh and take away some of the concepts, which we'll talk about, and you can apply those concepts into whatever you're building, a lakehouse or data fabric. There's a lot of hype on data mesh. It's not something that is easy. It's not something you can buy on eBay with a magic wand. Gartner has gone through the hype cycle with this. It's really at the peak right now. So a lot of misunderstanding and a lot of exuberance on it that is going to disappoint a lot of customers on that. Okay, what is a data mesh? It's made up of 4 principles. I've tried to simplify them here. It took me forever to come up with these 4 in this simplification, but it still may not be easy to understand. However, let me explain it. Principle number 1, domain ownership. The whole idea is, instead of copying the data to a central location, which is owned by IT, the people who know the data best, the domains, they will maintain ownership of that. If they're maintaining ownership, they're going to be able to clean it better than IT. So think of domain ownership helping out a big way in that aspect of it. And they are going to be able to support the data better because they know it best. And this is where you have to get into creating domains then. And it's not simply organizations within your company. Ideally, it would be that easy, but that's very rare. There's going to be a lot of shifting of personnel. So you may have a manufacturing, a sales, and supplier, generally broken up by business entity. And therefore, there could be overlapping domains, and the 3 Ds, as I call it, data-driven design, is very challenging. And so right away, that's where a lot of customers fail. They can't even create up their own domains on that. But assuming that you can do that, you divide everything up into the domains. Each domain is going to treat data as a product. And this is a principle that's most used outside of data mesh is to think of data as a product. But however, in the data mesh world, this is going to some kind of extreme levels. What that entails as a data as a product, because each domain is now building their own analytical data, means they have to hire teams to go build that analytical data. They need to build their own infrastructure. And then the analytical data they make, they need to make that available for other domains or consumers to use. So they may have APIs available that will return the data and the metadata so people can know what they have. So this could be a lot of work for each domain to go and push off what was the IT doing into the domains to go and build analytical data. Principle 3 and 4 try to help with that. So you can have dozens, if not hundreds of domains. You don't want them each going and building things from scratch. So principle number 3, this self-service data infrastructure as a platform, is the idea is there'll be a central team. So IT may still have value in this that will create maybe scripts that ideally the domain will say, we'll run the script and it'll say, what is your domain name? And it'll go and provision storage and compute and security and ETL pipelines and all these great things. There's no product that does all of that, not even close. So customers are rolling their own, on which has a lot of challenges that I'll get into. But the idea is let's make it easy for each domains to get up and running on that. And we do that by having these scripts or however automating tools that are going to provision those for customers for each domain. Along with that, you have all these domains. You don't want them doing their own security. You don't want them having their own data quality rules or data modeling rules. So you have another centralized team, which could be made up of individuals from the domains, are going to create these global rules that all the domains are going to follow. I can't have somebody using completely different security because people are going to want to join all this data together, and that's just going to be a nightmare. So the central team will define these rules. They may implement some of them, but the idea is to get the domains to do most of that. And this, therefore, even things like cleaning the data, we don't want one domain using state 2-digit codes and somebody using the full name, because now you got to combine all that data, and that's going to be a challenge in there. Imagine regulations that each domain's got to be following in there, and therefore that team is going to, if not help them implement it, at least monitor it to make sure they're all following those global rules. So what you wind up with is, and this is where people get confused, data mesh is not everything is decentralized. 1 and 2 are decentralized. Domain ownership data is a product. All the domains will have their own data and their analytical data in there, but there'll be centralized teams that'll create the scripts for infrastructure as a platform and for all the rules in there. So what data mesh really helps with are these 4 problems. Lack of ownership. Now it's defined. The domain owns it, not the IT team. And therefore, at least in theory, the data is going to be cleaned better and maintained and managed better. And that gets in the second point in that infrastructure team previously was getting this data, and they may go, I don't really understand this data. I'm going to try to clean it, and they may do it all incorrectly in there. And so that was always a issue and a lot of solutions that I've seen with customers. The 2 biggest things for data mesh are the organizational scaling and the infrastructure scaling in that. If I have these domains, each domain is now going to hire their own IT team. So the more domains I have, the more people I have. So I scale out and I solve that people problem. That leads, that is where you have a central IT team. As they're collecting more data, they have a limited amount of people. They're getting backlogged on that. They become a huge bottleneck in there. Well, now you have a lot more people, so that organizational problem goes away. And then the other is technical scaling. If IT is collecting all this data, it's centralized, they have it on a platform that could start getting overwhelmed. Well, now each of the domains have their own infrastructure. They're creating their own analytical data. Again, more domains, more infrastructure. And so I solve that scaling problem that occurs when everything's centralized. Now, this is where I have a big rebuttal to people who promote data mesh and say it's going to solve all these problems and every customer's got all these problems. Well, I've been doing this data warehousing for like 15 years, and technology's advanced, and people have built petabyte-sized central solutions on here. So it can be done, is being done. When projects fail, it's usually not the technology, it's the people in the process. Also talked in the book, but it's not the technology. And so sometimes I feel like data mesh is a solution looking for a problem. But we're going to get more federated solutions in there. They may not be a full-blown data mesh, but decentralization definitely can help, especially if those organizations within your company that are being decentralized are building their own teams and they hire good people. What a domain look like is this. This is a healthcare. You may have patient, clinical, claims, public health. Within each of those domains, you have products broken out here. This is where it takes forever for customers to come up with what these domains are going to look like, what the products are going to look like, and then go and implement those changes, which could be quite drastic. People hate change. So this is why a lot of customers struggle with going the data mesh route. Also, within a data mesh, you have a concept of domains that have source aligned data. For example, a supplier may create their own analytical data that everybody in the supply org understands. They understand the terminology and the way the data is all linked together. Some people outside may not understand that. And this is also what Jamek has proposed in their blog and book, is you'll have a consumer line domain where you can copy that data into a domain that is easier for other end users to use. So maybe I rename some of the data in there, the fields, and then maybe I join it in a certain way that makes it much more easier for a consumer who doesn't know anything about supplier to use that data. And then you'll have the challenge of performance. If I have dozens or hundreds of domains and I got to pull that data together on the fly, that could take forever performance-wise, be unacceptable. So she comes up with what's called an aggregate domain. So for example, listed here, I can have data from both the sales domain and the manufacturing domain aggregated and collected, and then that's used for performance reasons. So what you wind up happening is it can be very complicated. And this is where also people struggle with the data mesh, is I can have tons and hundreds of arrows going all over the place, and it's really hard to follow all that and maintain all of that. And then to me, I struggled with, well, if I now have a consumer aligned and aggregate aligned domains, I'm centralizing the data. Who owns that data? And this is going to get into the problem of organizational and technical scaling. So it sort of goes counter to what the data mesh is on that. So I really struggle with this part of it. But you're gonna have to come up with some solution to solve some of these problems, especially the performance one. So there's a lot of concerns I have with a data mesh. I won't go into them. I have a lot more in the book, but you probably already aware of, well, people don't like change, and their domains may, because the data mesh may take years to do. Domains may say, I don't want for the data mesh on there, or domains may go, I'm not hiring my own team. You want my operational data, take it, but I can barely keep things running. Now you're telling me I got to go and build out my own data lakehouse and make it all available to everybody else. Why should I do that? And if your response is, well, for the greater good, they may go, I don't really care about that. So that's just the nature of people. And that's why data mesh is only for a small amount of companies. And even Jamek in her book put this in here, where you have to score medium high on all these categories, which right away, honestly, is probably wiping out 99% of customers, because most customers are not early adopters, are not tech at core, they're not already domain oriented, they don't have long-term commitments. It goes on and on that. And so what winds up happening then is customers may, and I recommend go through, understand what a data mesh is, and you maybe just take bits and pieces of that to build your solution, but not go the full pure data mesh, I'll call it. So what I think will happen is, and there's a lot of exceptions to the data mesh that customers are building what they call a data mesh, but I would argue it's not even a data mesh, because what's the minimal viable mesh? Is it 3 principles you got to follow? Is it 2 principles? And then how much of that do you got to follow? I have customers that I look at what they built and I go, you're kind of following principle 1 and 2. It's more like a data lakehouse. I wouldn't consider this a data mesh. What they want to call it data mesh. Okay, and that what leads to the confusion in there. So keep that in mind too. There's nobody's building a pure data mesh. And what they may build is, I say call it whatever you want, maybe, as long as that solves your problems. But if you do go to the data mesh, a true data mesh, what you'll need to have some gradual approach to it. And that may mean, let's take some new data and we'll put that in the mesh. We'll have our central solution and we'll start out with a couple of domains, and then over time we'll pull more data out of the central solution and create additional data mesh domains. And really, you're going to have to do this. You can't just go and build a data mesh and flip a switch from a central location if you already have one in there. This also can solve the problem if a domain says, I'm not going to do a data mesh, take the data if you want. Okay, well, great. I'll just put it in the central data solution in there. And so this is where I think, where I've seen customers when they are building the data mesh, it's more like an agile approach. They do a little bit, they learn, and they continue building it on that. So in the end, with these 4 architectures, what do you see? What do I see with the solutions built on top of that? So I still see a modern data warehouse. It's generally very small amount of data. Customers new to the cloud, they'll use Synapse or even just maybe SQL database, and they don't need a data lake, and they'll put it all in there. And I always caution, you may not have a lot of data now, but what's going to happen in a year or two? And if you start getting a lot more data, you're going to have to go back to the drawing board and put in a data lake that you probably should have done from the beginning. The fabric, that's where a lot of customers are still going if they have a medium-sized amount of data and they're so used to the relational data warehouse, and they'll add a data lake to it, especially if they're migrating, but they don't want to go to the full data layouts. A lot of that is because, as an example, and I should write this down, that they have a lot of SPs written, and they don't want to go and rewrite all of them all to work with a lakehouse in there, which cannot support all the T-SQL that they've created in there. So they will say, we're going to have a relational and data warehouse in there, and we'll add a data lake in there, but maybe over time we'll get rid of those sort of procedures and go full data lakehouse, but for now we're going to have both. And but the majority of customers that I deal with, probably 90%, are going the data lakehouse route. Now I deal with large customers and other, you may be as much smaller, and so maybe those other solutions are better for you. And then the data mesh, if you have to be a very large company, you have to have a lot of problems already, a lot of pain points. You have to already be domain oriented. So a lot of the customers I see building the data mesh solution are finance, banking companies that already have a domain oriented architecture. So there's not an overwhelming amount of change that they have to go through. In the end, learn all these architect times, ways to approaches in there, understand the basic concepts, and then pick and choose what's going to work best for your use case. Unfortunately, there is no playbook that you can use that's just going to have flow charts where you can just go in there and say, yep, that's what I need. And I answered all those questions, and boom, here it comes in there. Everybody's going to be different on that. So it's up to you as an architect to gain that knowledge, understand all these approaches, and then pick the one that works best for you. And then keep at it, because 6 months from now, who knows what this next could be. There could be something else can come along, some power mesh or something So that's what's very challenging, is to keep up with all this. But I'm here to help you out, and that's why I have this presentation and the book. So last few slides, data mesh on Azure. A lot of customers are interested in this. You should respond right away. We'll go, wait a minute, isn't data mesh a cultural and organizational change and not about technology? Yes, that's why I only have a couple slides. So what Fabric has to put up with a data mesh is the ability to take workspaces that you created in Fabric and assign them or put them under an umbrella of a domain, which I kind of list out here. That's it. That's how you create a mesh. Well, the challenge then is the workspace. Somebody's got to define who's going to be in that workspace, and that's where you got to do that. Domain design is what people are going to be involved in it, and this is where I list here. If you look at the 4 principles, having this solution by domains is not doing much. It's maybe helping a little bit with domain ownership, but it's not really doing anything with data as a product. It's not really doing anything with principle 3 or 4. So it's taken you a step there, but just by the nature of data mesh being a culture change, there's not much that technology can do. Now, one way to think about this is that the data mesh can be built with each of the domains having a lakehouse in there, or one domain can have a modern data warehouse, one can have a data fabric. So they work together, and I always struggle with calling a data mesh an architecture, because it's, in some ways, it's really not an architecture. And the technology solutions inside of a data mesh would be data lakehouse and those other architectures in there. So they work together. There's not an either or choice in there. And so a big exception to the pure data mesh, where each domain has their own lakehouse, which is a data lake, is with the mesh in Microsoft's Fabric's view, and this is our best practices, is you're going to put everything in one lake. One lake is a giant data lake that is in one spot, we'll say. And all the domains then are not going to have their own lakehouse, but rather they were going to have their own workspace, or really folders inside of one lake. So logically it's separated, but physically it's all in one central location, which gives you the benefit of for performance and for monitoring, that everything is under one umbrella on that. And that's a big exception that people building solutions using Microsoft Fabric are when they build a data mesh. And pretty graphics here. And so another feature of one lake is the ability to have shortcuts. So I just talked about all the data centralized. However, you can have shortcuts to other data lakes. So that functionality is there, with the trade-off now, if you're doing that and you want to combine all the data, you have a performance problem there. You have copies of data that are outside the control of Fabric on that, which could be okay, and most likely would be in certain situations with customers on that. And so that shortcuts is a really cool feature in there. But you can think, when somebody goes in to look at one lake, it'll have shortcuts, but they're not even aware of it. It just looks like all the data is locally. And that's a really cool thing about Fabric in there, is having this virtualization layer that gives the appearance everything is unified. But be aware of those trade-offs of virtualization means you can have a performance hit. All right, so that's going to lead to me pausing for some questions here. There's a lot of follow-up links that I have on here, and I'll even plug, if you're going to data mesh route, a colleague, Pete Hine, has his own book called Data Management at Scale that goes very deep into data mesh and federation of the data on that. So you want to check that out. And so questions, I'm looking at the chat. I'm going to go from the newest ones. What is the future of SQL Server master data management? Isn't it a stale product? Well, this is unrelated to my topic, but I will mention that product has been abandoned many years ago. So don't use it. In replace of that, there's a lot of tools out there. I personally recommend Prophecy because I've been dealing with them for years. They're the people that actually built SQL Server MDM, and they created their own company. It's a long history, but their product's awesome. There's others out there like Calibra. MDM is an important part of all these architectures, so you want to look into that. For those that are not aware, mastering the data means just you could be pulling data sources that have all customer data, and there could be customers that are located in multiple databases, and you don't want to have them as separate customers. You want to aggregate each customer together. But what happens if their names are spelled differently? How are you going to know that they should be aggregated? And that's what MDM solves, among other things. Like Prophecy has a lot of data quality features in it that you could, and business rules you can put in there to help you with cleaning the data. Thomas has separate domains could also mean some common table repeating across domains, or is it MDM also a player for centralized common elements? So what I recommended, and I had it in the slide here, and I'm glad you brought that up because I didn't quite talk about it here, is that I list out this customer 360. This is really an exception to the pure data mesh, in that Geomic doesn't talk about having domains that have one functionality, in that I don't want each domain doing their own master data management. That's reinventing the wheel. I want to have all of that data mastered before it goes off into the sources. And so that's why I recommend having something like a customer 360. You may have other reasons where you want to join all the data, because you don't want to have all these domains all pointing to the source systems and pulling in their data and doing all sorts of the same repetitive cleaning of the data. Why is supplier cleaning the data from, in this case, Salesforce, and manufacturing is also doing that? So maybe we have to have a domain that's cleaning all that data and then passing it on. Now, you could also say, well, sales may take the Salesforce data, clean it, and then manufacturing will use it from there. But that doesn't work so well, especially with mastering data. So think through where you want to have domains that are and this is where, who owns that domain, who's doing that, and that's where some of the data mesh stuff gets very complicated. Nabil has, just by the decentralized nature of it, isn't it near impossible to align on a common standard for defining products? Yes. Next question. So that's the challenges, and I'm glad people are commenting about this, because when data mesh first came out, I said, oh, this sounds great, and I started thinking through it and go, well, wait a minute. And what you brought up was some of the things that I brought up in there. How are you going to have common standards in there? And so one of the exceptions I see a lot of people building data meshes to kind of avoid that problem, they have IT going and building the solutions for all the domains to get the same standards. But then that's taking away the big benefit of a data mesh, is people scalability on that. Now you're bottlenecked by IT in there, but a large majority of customers building data meshes are doing that. And so, okay, you get some of the benefits of data mesh, but not that big one. And then maybe, and some of them, the idea is, well, eventually we'll have domains go and have their own IT teams, but for now, IT's doing it. Okay, well, that's fine. Yeah, we'll send out the recording. Let's see, I think we got Julia says, will you call data mesh the use case when each domain has its own analytical solution and supply their own data as a product, but some of the source data of those analytical solutions are shared between domains? Yeah, I kind of touched on that. So this is where, again, with 360, maybe you have, like you said, financial data. Maybe you do some of that. So this is where nobody's going to build a pure data mesh. Everybody's going to have exceptions to it. And one of them, maybe they centralize some of that data and do things with it before it moves on. So yeah, have exceptions to it. You may have so many exceptions that you don't call it a data mesh anymore, or shouldn't. and I've seen that with a lot of customers, but do what's going to work for your particular use case. Don't go by the pure data mesh and I have to do it that way, because you're gonna fail. And let's see. If Nabil says if the MPP data warehouse is expensive and your data volume is not large, is a relational data warehouse sufficient? When I talk about relational data warehouse, I generally am talking about like a Synapse dedicated pool on that with the MPP technology. If you don't have a lot of data, that could be SQL database on that. It could be SQL Server and a VM if you want to go a little more old school in there. That could be sufficient if you have a small amount of data, by all means. But as I mentioned before, if you're going to add a lot of data down the road, that's going to fail. So think through that. And a lot of customers say, we'll never have that amount of data. And a year later, they're like, uh-oh, we didn't expect all this data. Because once you start giving end users things that they really like, dashboards and reports, they go, this is awesome. Can you add this data? Can you add this data on that? And then you're like, oh boy, now what have I got myself into? I should have thought through this from the beginning. All right, I think that's it. Whew, I went over. I apologize for that on that, but I did get through all that. If you did not get your question answered, or you just didn't want to mention it during this call, there's my email. Feel free. I'll sometimes even jump on a call. I love talking about this stuff. And if you buy my book, I'll really like and enjoy talking to you. But no, I'm just kidding. But feel free to reach out, because I enjoy hearing different use cases, and I learn a lot too just by hearing the questions that I'm asked.
Well, thank you so much, James. I know you probably likely are going to get at least 40 pre-orders for the book. That was a great session. I put the link for your book in the chat. I will put it out in the communication that follows up afterwards, but we thank you for everybody joining. This was a very interesting topic, and we can tell that the audience was really engaged with it. So thank you so much again, James, for joining us, and thanks everyone for spending the time with us, and we look forward to seeing you in February at our next session. Thank you so much, everyone. Have a great night.
Thanks all. Take care.